Hey physicists, just a quick little rundown on what you'll be doing today. If you're watching this video, you've already found Schoology. Let's go to day one. Here you can see the agenda. Pause on that if you'd like to. We're going to forego the reading check as I'm out of the classroom today. Let's go ahead and open this up. The project that we're going to be working on today will be this simulation. The worksheets that will guide you through it are found here and here. Most computer users will use the Google document worksheet net force and motion. For iPad users, please go ahead and download the worksheet net force and motion version 1.docx and change that to a pages file. Let's go ahead and open this up. We'll go ahead and file, come down here and make a copy of that. Change the name so that your name is the last part of the file name. There are two major sections that you'll be working on. One is net forces, this little tug-of-war game. I'll describe how to access that in just a little bit. Answer a few questions about lining up your forces on each side by the various people. Enter your answers in each of these boxes. And most importantly, the time to win from go. You can do that by just counting 1 Mississippi, 2 Mississippi. You can look at a clock or a watch as well. Go ahead and answer these reflection questions down there. The second section is on changes of motion from unbalanced forces. It's just another option on that same simulation. You'll see again that you have a series of tables to fill out. Notice here you have a force, mass in kilograms, and change in speed. Just want to talk a little bit about that. You'll see in the little simulation that our sim man, as I call him, can start pushing anything from stop motion up to 50 meters per second, but he can't go any faster than that, so he falls down at 50 meters per second. A nice way of determining the acceleration is that you know the change in speed is from, or change in velocity is from 0 to 50 meters per second, and just divide that by the time. Take a look up on the front board of the classroom, you'll see those calculations. And again, acceleration is our change in speed divided by our change in time. Our change in speed is fixed, 50 meters per second. You'll have to supply the time. First chart involves the same mass and various forces. Second chart involves same force, various masses. Okay. And then just work your way through these various questions. Answer where it does say your answer. At the end of the period, make sure you save this as a PDF and submit it to the assignment. The assignment can be accessed over here on the right side. You can also find it right here. Once you click on this, you'll find that there'll be a submission button on the right side. If you'd like to see what the rubric looks like, that's right here. To access the simulation, you can use this link right here, simulation link, motion and forces. There's also a link embedded in the Google document or Microsoft Word, the .docx file as well. If you'd like a little more on how to use this simulation, you can look at that video. But I'll go ahead and I'll click on this link. You can see what it looks like. Here's the simulation itself. Okay. One of the simulations will be this one called Tug of War. Let's go ahead and put a few people up here. Big, strong red guy here, and pull. See how that works? Make sure you please turn on the sum of forces, which is also known as the net force. We call it net force. They use the term sum of forces and values for each of these. After you're done making all the measurements on the tug of war, come down here, go to the motion video. Here again, select all of the options here, and you can end up grabbing different masses and apply different forces by pushing the toggles on this side. So you start speeding up. And just a note here, you can see the speed is increasing. This is pretty much from 0 up to 50 meters per second. As I mentioned, our guy Simman here can only run or push up to about 50 meters per second. So watch what happens here, pushing faster and faster. Yeah, he ends up falling down at that point. What's handy about that is if we time from the time he applies his force till he falls down, we can get the amount of time it takes for him to change the motion, or the motion of the boxes, 50 meters per second, because he starts pushing obviously at 0 meters per second, falls down at 50 meters per second. Just a quick reminder, this is due at the end of the block. Make sure you save this as a PDF and submit it through the assignment on Schoology. Good luck.